So this video is for if you missed class or if you missed something in class. And so 6.4 is about inverse functions. And we've already talked about inverses, like inverse operations. Addition and subtraction are inverses. Multiplication and division are inverses. Another one, if you had like 5 squared or x squared, the inverse of a squaring function is a square root. So that cancels out. If we just do square root of 5 squared, that would just be 5. So those are 3 examples of inverse operations. But what happens when we look at functions? So this warm-up, I was just trying to get you to use inverse operations to solve these equations and get used to inverse operations. So to move this 2x over to the other side, we have to, since it's positive, we have to subtract, which is the inverse operation. And then this cancels out. And then to move the 14 to the other side, we subtract. Okay, and then we simplify. 3x minus 2x is x. And negative plus a negative is a negative. Okay, and then this one, again, we're using inverse operations. So if we want to solve this for y, we have to move the 5x over to the other side by using the inverse operation. Then we still have 2y equals negative 5x plus 10. And now what's the inverse of multiplication is division. So we divide by 2. And then we simplify. Negative 5 over 2 times x plus 10 over 2, which is 5. So then going on to some graphs of inverse functions. And this is going to be something to keep in mind for every inverse we do. Let's say f of x is the original function. That's this red line. But f inverse of x, that's what this minus 1, f to the minus 1, means inverse function. And so eventually we'll learn how to find these equations, this x minus 1 over 2, but that's this blue line. Okay, and then notice this line in the middle is called line of symmetry. It's y equals x. It's just a line that starts at the origin and it has a slope of up 1 over 1, which is positive 1. Okay, notice the symmetry going on here. First, if we look at these 2 points, they are the same distance from this point. If I draw a line there, it's up 2 units, and here it's over 2 units. Same with if I go from this point and this point to that point on the line. If I were to find the distance of this segment and that segment, they'd be the same. And so we get this line of symmetry at y equals x. This will always be true for 2 inverse functions. So the other thing that happens is the domain of f of x becomes the range of f inverse of x. And so what I mean by that, domain is the x values and range is the y values. So notice this point here and this point here, they just switch. The x and the y's completely switched around. 1, 3 becomes 3, 1. Here's another example. 6, 13 becomes 13, 6. And so the range of f of x is also the domain of f inverse. Another way to say this is just x's and y's switch. That's the less fancy way to say it. The third thing that we already talked about is that the graphs are symmetric about the line y equals x. That's just the fancy way to say this line of symmetry. Again, what I was saying about the distances between from the blue line to the green line and from the red line to the green line should be the same. They should be symmetric. So then moving on, how would we actually find an inverse function? If we're given, another example. This is another example of exponential and logarithmic functions. You may have heard of these, especially with Corona. Some graphs give you exponential look, and other graphs give you a logarithmic look. And these are inverses because you get this symmetry. This distance is the same as this distance. Notice the x and the y just switched. X and y switched. You get the same distance here, same distance here. It's symmetric. And you've got the same line, y equals x. But as I was saying before, how would we find the inverse? So if we're given f of x equals 5x minus 2, this is a straight line. How do we find the inverse function, which would be symmetric to it? So how do we find that? Well, it's the same process every time. So let's get used to it. What we need to do, let me pick a color here, is first change f of x to y, because we're used to working with y and x instead of f of x. And now, since I said before, the domain and range switch, the x's and y's switch, that's the first thing we want to do in our equation. So I'm going to change y to x and change x to y, but leave everything else the same. So the equals and the 5 and minus 2. So we're doing 5 times y and still minus 2. Now we just want to solve this equation now for y. It's already solved for x. And once we solve it for y, what we will have is the inverse. So to do this, we have to follow order of operations sort of backwards. We want to leave any multiplication and division for the end. So the first thing we want to do is add 2 to both sides. And we get x plus 2 equals 5 times y. And now we undo the multiplication with division. Okay, and we have x plus 2 over 5 equals y. We're basically done. This is the inverse function, x plus 2 over 5. Okay, and you can kind of see if you look back at the original, we used to have 5 times x, now we have divided by 5. We used to have minus 2, now we have plus 2. But you may not really figure it out, just kind of, there's not really a shortcut other than what I just did. You could write this another way and say, well, this is 1x divided by 5, which is 1/5 x, plus 2/5. This is another way of writing the same thing. These would be the same function, the same line with a slope of, this version is just nice because it's slope-intercept form. And we can see the slope is 1/5 and the y-intercept is 2/5. So that way we could actually graph these functions and see the symmetry. Okay, another example of how to find the inverse. And I see right here, I just left it in this other form, x plus 2 over 5. So we could go to Desmos and type these in, actually. 5x minus 2 and x plus 2 over 5. I'm going to pull up Desmos, my Desmos calculator, so you can see the symmetry that I'm talking about again, and that it is, in fact, the inverse. Y equals 5x minus 2. Y equals x plus 2 over 5. And you can do this on your own, too. Okay, now, it's kind of hard to tell unless we put in the line that they're symmetric about, the y equals x. And now we can really see these lines, the red and the blue, are symmetric. And if I pick some points, if I make a table of values, if I pick x is 1, if I plug in 5 times 1 minus 2, I would get 3. So there's on the red line. Now if I just make them backwards, that's on the blue line. That has to be true that way. If I try 2, plug in 2 times 5 is 10, minus 2 is 8. And now I just switch them, 8, 2, and there you go. So let's go back to my PowerPoint and let's do another example of how to find another one. So we're given f of x, or y equals 1/3 x minus 2. We want to find the inverse. So again, the steps. Step 1, we want to write out step 1, switch x and y. So x and y. Step 2, solve for y. So I add 2 on both sides. I want to do addition and subtraction first. Leave any multiplication or division for the end. Now, how do we undo 1/3 times y? You might be thinking, well, we could divide by 1/3, but that's the same thing as multiplying by 3 over 1. I think that's a little bit easier. So then we have to multiply this side by 3 over 1, which is just 3. So then this all cancels out, and we distribute 3x plus 3 times 2. Okay, and that's our inverse. 3x plus 6 equals y, or we could say f inverse of x. We don't want to say f to the minus 1. That's not how you say it. It's f inverse of x. Okay. So let's do another one. what if our function looks like this? Y equals 2x minus 1 over 5. We just want to leave it like that. And now it doesn't say to find f inverse of x. It actually has a number in there. And so what we definitely do not want to do is just plug in the 3 in for x. That would be finding f of 3. Okay, that's not the same as f inverse of x. Those are not the same thing. So we need to find the inverse first. Find inverse first, then plug in 3. So remember the steps. Step 1, switch the x and the y. Step 2, solve for y. So how do we get y by itself? Whenever you have division, a big division bar like this with like a binomial on the top, we want to just multiply both sides by the denominator if it's a number, and that will cancel out that number. So next thing we have is 5x equals 2y minus 1. And now remember, we're solving for y, so we need to add 1 to both sides. Let's write this over here. 5x plus 1 equals 2 times y. And the last step here is divide by 2. Okay, and we could leave this like this, 5x plus 1 over 2, because what we really want to do now is plug in 3. Plug in 3 for this x. So 5 times 3 plus 1 over 2. And now follow the order of operations. This is 15 plus 1 is 16. And then divide by 2 and we get 8 for our final answer.